Same day for me, different section for you. Now we're heading on to chapter 4, section 3, congruent triangles. And this time I am going to use the PowerPoint. And it says that it's PowerPoint for point 2 because there was one year where I taught them both together on the same day. And I assigned them like that, but I'm not doing that this year. So a very short lesson on this section, which is called congruent triangles. It's called congruent triangles, but they're just going to go ahead and define for you congruent polygons, okay? Because it's true for all polygons, and but we're in the triangle chapter, so here we go. The example they're using is a triangle. Two congruent, so if you recall the definition of the word congruent, some years I get kids and they're just like brainwashed. Congruent, same shape, size, like immediately they know it. So kudos to whoever that teacher is that taught you that. If not, then I'm letting you know that that's a thing, same shape, same size. So if you have congruent polygons, same shape, same size. Two polygons are congruent if and only if their corresponding parts are congruent, because it's easy to see how an angle could be congruent to another angle. They would have the same measure, or a line segment. They would be the same lengths. But if you have a whole shape, and in this case it's a triangle, then every corresponding part has to be equal. So it's not saying that I have to have equiangular, equilateral triangles. It's just saying that the two different triangles that I have, or polygons, it doesn't have to be a triangle, every corresponding part has the same measure. So this is where it's going to be a little tricky. You have to make sure you're paying attention to, are we talking about degrees? In that case, we're saying the angle measures are equal. Are we talking about centimeters or inches or units? That's going to be the side lengths are equal. And it has to have all of them. So in these two triangles, and they have it completely color coordinated. So angle A and angle H are both red, and those are the two angles that are congruent. Okay, that means they have the same measure. And look, they put two arc marks on them. Angle B and angle J are the same measure. They're congruent to each other, and they both have one arc mark. And the same thing with angle C and K, and they made them both green. Okay, and then the other thing to notice is that they have, so those are the corresponding angles. They match up together. Like if I twisted this around, I could plop it on top of the other triangle, and it would be, everything would have the same length and angle measure. Okay, so the corresponding sides, since angle A and angle B, since angle A and angle H, since those two are congruent, H would have to be flipped around and land on top of this. And so the side between angle A and angle B, on this triangle, it's the side between angle H and angle J. Those are corresponding sides, and they both have one tick mark on them. Okay, and so between B and C, that side length, they put two tick marks, and then J and K, that has two tick marks, okay, and they have the same measure. Angle A and angle C, the side between them, angle H and angle K, the side between them, they both have three tick marks, so they have the same length. Okay, so since we're talking about a triangle in this specific example, there's three angles in each triangle, and there's three sides in each triangle. So there's 6 different pieces of information that I can glean from the fact that someone told me that these two triangles are congruent to each other. So this is called a congruence statement, and part of the assignment will be to write a congruent statement. That means you're going to name the shape. So let's say, okay, in this first shape, triangle ABC. That could have been a random the way they named it. Okay, that is going to be congruent to triangle HJK. That has to be in that order now, because look how the two that are red are first, because they have the same angle measure. The B and the J are the middle ones, and the C and the K are the middle ones. Another way I could have named this triangle, I don't have a triangle symbol on my keyboard. If I would have called the first triangle BCA, and I also don't have a congruent symbol, I'm going to write is congruent to triangle. I'm going to leave a space. I'm going to draw a triangle symbol in there. Now, the way you know what it's congruent to is by saying, okay, so if I put B first, let me go ahead and draw the triangle symbol right now. So triangle BCA, oops, different color. Triangle BCA. Okay, B is first here, and B is blue. So J has to be first in the next triangle. Triangle J. And then what did I name second? I named the C second, and the C is green, and it has 3 arc marks, and it corresponds with K. That's what corresponds means. It's in the same spot, have the same measure. And then the last angle A, that has 2 arc marks, and this other triangle, it's H. So this congruent statement, and instead of writing out the word is congruent to, when you write a congruent statement, you could just type, I mean, not type, you're going to be handwriting it. You could remember it's an equals with a squiggly on top. That means is congruent to, okay? Triangle BCA is congruent to triangle JKH. Alrighty. And then my next example, I have an example. Let me clear the drawings. So in this diagram, triangle ITP is congruent to triangle NGO. Find the values of X and Y. Okay, when they tell me this congruent statement, that's all the information that I need. Now I know that angle I, the measure of angle I. See how why they don't usually use the letter I to name angles? Because it looks like a number 1. Okay, the measure of angle I is going to equal the measure of angle N. Another way they could have written it would be to say angle I is congruent to angle N. Ugh, that's an equals with a squiggle on top. Angle I is congruent to angle N I know that because I know the definition of congruent triangles, congruent polygons. The definition of congruency means they have the same shape and size. So since it's an angle, that means their measures are equal. That's why I can write these 2 statements. It's a subtle difference, and it'll be important later in geometry. So did they give me one of these 2? Yes, they gave me angle I is 65 degrees. And what did they give me for N? They didn't give me angle N. They gave me angle O. Darn it, I wrote that all out. It doesn't even help me solve for anything in the triangle. I need to find X and Y. So, but anyway, it would have been whatever that is. A big old question mark. Yep, 65. I just know, well, I'll write it in there since I spent all that time writing it out and didn't need it for anything, I don't think. Sometimes you might need things like that. This is a 65-degree angle. All its glory. These are both 65, but that's not what I needed. I wanted to use this one. Angle O is the one that they gave me as an expression, and I need to find the values of X and Y. So angle O is going to equal angle P, and angle P is 40 degrees. So the equation that I'm going to end up solving is that the 40-degree angle, angle P, is going to equal 6y minus 14. 6y minus 14. And then I can solve that for y, and then I can use that value to get x. And notice that this is an angle measure. So when they gave me 6y minus 14 degrees, I have to remember, wait, I'm using degrees here. So when I go over here and look at the O, I mean, not the O, when I go for the P, don't get confused and accidentally use the 13 or the 11. Don't ever set, like over here, x minus 2y, that cannot equal like 75 degrees because x minus 2y is the length of NG. Okay, let me erase my drawings. I believe I have this all here in the PowerPoint. Whoops. Okay, so starting with angle O is congruent to angle P. They're going to solve it and substitute in the, oops, sorry. 6y minus 14 equals 40. Okay, and remember we knew that O and E, it was equal to P because of congruent, because of the original congruent statement. Those letters were the last letters in the original congruent statement. Oh, and that's all I showed you. Okay, so that's what I wanted to know. Find the value of X. You would know that, here we go. Oops, I have Zoom things in the way. All right, to draw this, okay, so X minus 2y is side NG, And this is how you can find it. Okay, go back to that original congruent statement. NG were the first two letters, and IT are the first two letters. That's how you know what to set equal to each other. So NG, the length of NG is going to equal the length of IT. And so X minus 2Y, I'll type it so it looks nicer. X minus 2Y is going to equal length of IT, which is given as 7.5. Okay, because going back to my drawing tool, NG and IT were the first two letters, and IT is this side. So that's how you know to use the 7.5 and not like the 75 or the 65. That's a way that people mess up. And you would solve that by taking the value that you got for Y here. When you solve, if we finish solving this, it would be 54 divided by 6. 6 times 9 is 54. So it would be 9. You would put a 9 in here, and then X minus 18 equals 7.5, and you would get a decimal answer, but that's okay. Alrighty. See if I want to go over this next example or if I'm done. Third angles theorem is something that we'll use in the future, but I don't need to really mention that to you yet. And done with another video for you. Chapter 4, Section 3, Congruent Triangles.